Hi, scholars. Happy Monday. Today is Monday, May 4th. Today, we are starting a new unit on a review of adding and subtracting fractions. Very few announcements for this morning. You did not have a new assignment on Friday. Already did lots of shout outs and lots of Vista Virtual points for excellent work on Spiral Review number 2. That is now closed. You can check your grade on Spiral Review 2, and you are well on your way to working on Spiral Review number 3. So we're just going to dive right into our math today. Got some fun problems for today. Do make sure you are set up with your blank paper, with your pencils, ready to go. And just a last reminder to make sure that you come to social lunch today at 11:40 to check out who is winning all of those prizes. Cannot wait to see all those exciting announcements on who is winning those prizes. All right, so it has been very hot, as you guys know, and I've been home a lot, as all of you guys have as well, and I actually have a lovely lemon tree in my backyard. And as it gets hotter, all the lemons start falling off, and you have to use them up before they kind of dry out and they aren't so good anymore. So I made up this recipe for raspberry lemonade. It's actually like a raspberry lime lemonade. It's really, really good. So I'm going to share with you my secret recipe for how to make this delicious raspberry lemonade. We're going to figure out how much of each ingredient I need to add, how much we're going to end up with all together. And then if any of you have lemon trees in your yards, or if you just happen to have a lot of lemons at home, I would highly suggest you try it because it is quite delicious. So let's just take a look quickly at my recipe, all the ingredients that you need to make my famous raspberry lemonade. You do need 4 1/8 cups of water. You need 6/8 cups of lemon juice, 3/4 cups of sugar, 1/6 of a cup of lime juice. That's kind of my secret ingredient. 1.5 cups of raspberries. You can't have raspberry lemonade without the raspberries. And then I like to add 1 1/3 cups ice. Of course, it's really hot. I like my lemonade to be nice and cool. So I have for you here all of the different steps that we're going to take as we make my famous raspberry lemonade. You're going to help me figure out how much I've been adding as we add different ingredients into our pitcher. You do need some kind of pitcher or jar or just something to put all the ingredients in. So the very first thing you do when you're making my delicious raspberry lemonade is we mix the water and the lemon juice in the pitcher. And I want to know, if we're mixing the water and the lemon juice, well, how much is actually in the pitcher? So I'm going to set up on my scrap paper for question number 1. First, we should figure out, okay, I'm mixing in the water and the lemon juice. So let's see if we can use a recipe to figure out what this is to go ahead and write an equation. So I'm looking for how much water we're going to be adding. It looks like we need to add 4 1/8 cups of water. And then we're going to mix that up with the lemon juice. We do need 6/8 of a cup of lemon juice. So on your scrap paper, go ahead and write what this equation would look like if we were going to add our water and our lemon juice. All right, and you can check to see if your equation matches mine. I have 4 1/8 plus 6/8 to add our water and our lemon juice. All right, so we think back to how we add fractions. We spent a lot of time, 5th graders, on that skill this year. Let's make sure we remember what to do. First thing I want to do is check to make sure we have a common or the same denominator. So I'm going to look at my denominator. I have eighths and I have eighths. I have the same, or I have a common denominator. This is great news. I'm actually ready to add my fractions. Now, unlike multiplying fractions, where we multiply the numerator and multiply the denominator, we know that when we're adding fractions, our denominator stays the same. If I wanted to draw this out, so it'd be like 4 whole cups, and then 1/8 of a cup, so 4 whole cups plus 1/8 of a cup. This is how much water I have, and then I'm just adding that to 6/8. 1, 2, 3, 4, 5, 6. And so my denominator, 8, those are already the same. I'm going to keep those the same. I have 4 wholes, so I still have 4 wholes. And then I'm just going to add up my 8s all together. To do this, I can just add my numerators. So 1/8 plus 6/8 is 7/8. I can check that with my picture. I have 1, 2, 3, 4 wholes, and then I have 1, 2, 3, 4, 5, 6, 7 eighths. Nothing about my denominator changed because I'm just working in eighths. Now, we spend a lot of time adding fractions already. We know how to draw models. If you ever get stuck and need to draw a model, you can. We're not going to be doing a lot of model drawing today because we actually know the rules about adding fractions. As long as I have the same denominator, I just add my numerators and my denominator stays the same. So I know that if we want to go back and answer our question of how much is in the pitcher, well, we actually have 4 7/8 cups in our pitcher. That's how much we have when we added our water and our lemon juice. All right, step 1, but we're not done yet. That wouldn't make very good lemonade. Let's take a look at question 2. So you want to make this lemonade a little healthier. So you don't add all of the sugar. We're actually going to reduce the amount of sugar by 1/3 of a cup. So I want to know, how much sugar will we add? All right, so we're looking for the amount of sugar that we're going to be adding, but we're going to reduce it by 1/3 cup. Reducing it just means we're going to take it out. We're going to eliminate it. I'm trying to be a little bit healthier, want to make sure I don't get any cavities since you can't go to the dentist right now. So we're going to take out 1/3 of the cup of sugar. So let's quickly check in with our recipe. Okay, the recipe calls for 3/4 cups of sugar, but I'm not going to add all of it. I'm actually reducing it or taking out 1/3 cup. Go ahead and write the equation, number your paper number 2. What equation or number sentence matches how much sugar we're actually going to add? Remember that the recipe calls for 3/4 cups of sugar, but we're eliminating or reducing or taking out or getting rid of or subtracting 1/3 of a cup. All right, check to see if your equation matches mine. I know the recipe calls for 3/4 cups of sugar, but I'm taking out 1/3 cup. So I need to figure out how much sugar am I actually going to be adding. All right, subtracting fractions. It works exactly the same way as adding fractions. The first thing I need to do is check to see, do I have a common or the same denominator? And when I check, I have fourths and I have thirds, not the same. So I cannot subtract across and say 3 minus 1 is 2 and 4 minus 3 is 1. It just doesn't work that way. We didn't say 8 minus 8 was 0. We're not adding and subtracting our denominators. I want to know, if I have 3/4 and I were to take away 1/3 of them, how much is left? So luckily, we're already experts at finding those common denominators. So I'm going to go ahead and set up both of my fractions to have the same denominator. To do this, I'm going to ask myself, what multiple do 4 and 3 have in common? And I could do this by just skip counting by 4s and skip counting by 3s until I find a number they both have as a multiple. So let's say I'm going to start with 4. 4, 8, 3 doesn't go into 8. I'm not going to get to 8 if I skip count by 3s. 12. 3 will go into 12, so I'm going to use 12 as my common denominator. I'm going to go ahead and set up my new fraction with 12ths. All right, now I need to figure out, well, how many 12ths is 3/4? And we did so much practice with this throughout the year. I know some of you are just experts. You can go ahead and solve it on your own. I'm going to think, how did I get from 4 to 12? Well, I multiplied 4 times 3. That's how I got to 12. And whatever we do to the denominator, we do to the numerator. So 4 times 3 is 12. That means I need to multiply my numerator also by 3. And so I'm going to get 9/12. 3/4 is equal to 9/12. I'm going to do the same thing for 1/3. How did I get from 3 to 12? Well, I multiplied by 4. So 3 times 4 gets me to 12. If we do something to the denominator, we do it to the numerator. So much practice with that. And so if I multiply my denominator by 4 and multiply my numerator by 4, 1 times 4 is 4. And now I can subtract. Now I have the same denominator. And so all I need to do is subtract my numerators. So let's go ahead and subtract. My denominators will stay the same. And I can subtract. If I have 9/12 and I take away 4 of them, I'm left with 5/12. Check that yours matches mine. All right, so we had 4 7/8 cups of water and lemon juice. And we figured out we're going to be adding 5/12 cups of sugar. Make it just a little bit healthier than the original recipe. All right, we're rocking and rolling. Let's see what we're going to do next. All right, the next step of our recipe calls for adding sugar to the lemonade. I'm actually going to pause for one second. I'm just going to write down these answers. I just want to make sure everybody knows how you can record fractions on a computer. For number 1, we figured out that we have 4. So I'm going to type in my 4, and I'm just going to leave a space, 7/8 cups of water and lemon juice. Notice that I just used the slash bar to show my fraction. Here, I want to know how much sugar am I going to add? Well, we're going to add 5/12 cups of sugar. All right, step 3. Next, we're going to add the sugar to the lemonade. And we want to know how much is in the pitcher now. Well, that makes sense. I have my 4 7/8 cups of lemonade, and we're just going to add the sugar. Not all the sugar from the recipe, just the sugar that we are going to add. Remember, we're being just a little bit healthier. So now I want to know how much is in the pitcher now. For number 3, go ahead and set up your problem on your paper. What would this look like if we're adding the sugar to our lemon and water mixture? All right, let's check in. I'm looking at 4 7/8 plus 5/12. Check to see that you also got this. All right, and now we're ready to add. All right, first thing I do is I check to see, do we have a common denominator? We don't. We have 8s and we have 12s. So my job is to find a multiple, a common multiple that both 8 and 12 go into. I'm going to then set up my new equation with that new fraction. Now, my whole number 4, this can actually just stay the same. I don't need to change anything about that. So I'm just going to go ahead and bring down my 4. I know I'm going to be changing my fraction to that common denominator I can skip count by 8s. I can skip count by 12s. What multiples do they both have in common? Let's start with 8s. 8, 16, 12 doesn't go into 16, 24. 12 goes into 24. So 24 is my common denominator. I'm going to turn both of these into 24ths. Now I need to figure out how many 24ths is that. You're trying this on your paper along with me, thinking back to our strategy from number 2. I asked myself, what did I do to 8 to get myself to 24? What did I multiply by? That's right, I multiplied by 3. So if I multiply my denominator by 3, what do I need to do to my numerator? Okay, go ahead and do it. We do the same thing to our numerator. So you can go ahead and figure out how many 24ths and 7/8. Go ahead and write it on your paper. All right, so 7 times 3 is 21. Go ahead and try 5/12 on your own. I'm going to do it up here. I want you to try it on your paper. This is excellent practice. Ask yourself, what do we multiply 12 by to get to 24? If we do it to the denominator, do it to the numerator. All right, check to see what you have. We should have 4 and 21 24ths plus 10 24ths. All right, now that we have the same denominator, we are ready to add. So my whole number, I'm just going to keep that the same and add my 24ths. 21 plus 10 is going to be 31 24ths. All right. Now, mathematically, this answer is correct. I will have 4 and 31 24ths cups in my lemonade pitcher. But as we know, this isn't the most proper way of writing it. We might call this that improper fraction. It just looks kind of funny because our numerator is so much bigger than our denominator. So we remember that when we get an improper fraction like this, we just want to reduce it so that our numerator is smaller than our denominator, because it's a lot harder for me to measure out 4 and 31 24ths cups. I'm just not sure exactly how much that is. So in order to turn this back into just a regular proper fraction, I'm going to take out the wholes. Now I know there are 24 24ths in one whole. Now my 4 is just going to stay the same. I'm going to take out 1. So I'm going to subtract 24 24ths. That's equal to 1. And that leaves me, I already have my common denominator, 24, my 24th. So I just need to do 31 minus 24, which gives me 7. This looks like a much more proper fraction, 7 24ths. Now, I already had 4 cups. I have 1 cup from my 24 24ths, and then I'm left with 7 24ths. So I need to add all of these together. 4 plus 1 is 5, plus 7 24ths, and this gives me a total of 5 and 7 24ths cups. So how much is actually in my pitcher right now? 5 and 7 24ths. I figured this out by first finding my common denominator. Didn't need to do anything to my whole number. After I added, I got the mathematically correct answer of 4 and 31 24ths. We just wanted to make it look a little bit better. We kept our 4 as our whole number the same, and then we subtracted those 24 24ths, which I know is equal to just 1, which left me with those 7 24ths. All right, so how much is in the picture now? We now have 5, I'm going to do a space, and 7/24 cups. This is how much is in my pitcher right now, but we are not quite done. All right, step 4. Sadly, the store was out of raspberries. They seem to be out of so many things these days. So I'm missing a fourth of the cup of raspberries. How many cups of raspberries will we be able to add to our lemonade, knowing that I'm going to be short or I'm missing or I have to subtract 1/4 of a cup? So I'm missing these raspberries. Let's check our recipe. The recipe calls for 1.5 cups of raspberries. Go ahead and for question number 4, go ahead and write your equation for what this will look like if we were supposed to add 1.5 cups of raspberries, but we have to take out or subtract or reduce, eliminate 1/4 of a cup because we just couldn't find them at the store. Go ahead and write your equation. All right, see if yours matches mine. I know that the recipe normally calls for 1.5 cups of raspberries, but I have to take out 1/4. I just don't have enough. I tried to go to the store and get more. They were out, and this is all I have left at my house. So let's figure out how much is that. All right, first thing I need to check for is, do I have a common or the same denominator? I have a 2 in my denominator right here and a 4, not the same. Let's go ahead and turn these into a common denominator. I want you to try this on your own. Let's go ahead and set up our new equation. I keep my whole number the same. I'm thinking about what number both 2 and 4 share as a multiple. And let's see if I count by 2s. 2, 4. Oh, 4 is a multiple of 2. So I can turn both of these into fourths. All right, as I think about how did I get from 2 to 4? Well, I multiplied 2 times 2. Do the same thing to my numerator, which means I have 1 and 2/4. Now, with 1/4, we're in luck. I didn't have to do anything. So if I'm keeping my fourths the same, I get to keep my numerator the same. And that one's nice and easy breezy, mac and cheesy, no extra work there. And so now I can subtract. Now I have a whole number 1, and I know I can actually do 2/4 minus 1/4. So I can just keep my whole number 1 and then subtract my 2/4 minus 1/4, which will leave me with 1/4. So it's not the end of the world. The recipe did call for 1.5 cups of raspberries. I'm going to be able to add 1 1/4 cups of raspberries. I'm going to type that by writing my 1 and then 1/4 for my 1 1/4 cups of raspberries. All right, let's see what we need to do next. So I'm adding this 1 1/4 cups of raspberries, but I don't put it in the lemonade right away. Instead, this is my secret trick. This is what makes it so good. I'm actually going to put the raspberries in a bowl and add the lime juice and stir it until all the raspberries are covered in lime juice. So I need to add my raspberries, and we're adding the lime juice. And we want to figure out how much is in just this bowl. Now, I'm not going to use the amount of raspberries in my recipe because that's not what I can really add. So instead, go ahead and set up your equation. How many raspberries are we adding? And how much lime juice? This I can just pull right from my recipe. And we're just trying to figure out how much is going to be in the bowl when I mix those raspberries and my lime juice. All right, your equation for number 5 should match mine. I want to challenge you to add this one. Go ahead and try this one on your own. So I'm going to be doing mine up here. You're going to be doing yours on your own paper by checking for that common denominator. You can check to see if your common denominator matches my common denominator. And then go ahead and check in to see if your answer matches mine. The common denominator that I chose was 12ths. It's not the only one, but that is the smallest one. I need to get to 12ths. I would need to multiply 4 by 3. So I did the same thing to my numerator. I knew in order to get from 6 to 12, I would need to multiply by 2. So I did the same thing to my numerator. This gave me 1 3/12 plus 2/12. I kept my whole number and added my fractions by adding my numerators, and I got 2, 1, and 5/12. So that is the amount that's just in my bowl. It's just my raspberries, and they're all mixed up with lime juice. Again, this is the trick that makes it really good. All right, so 1 and 5/12. So I'm gonna type 1, leave a space, and 5/12. That's just how we type it into the computer. Cups. Okay, we're getting close. Can almost taste that lemonade already. Step 6. Now we need to add the raspberries and the lime into the lemonade. So I have my bowl that has the raspberries with the lime juice. We're just going to be putting that into the pitcher of the lemonade. So I need to figure out, okay, how much was in this this raspberries lime. We're just going to add that into our lemonade. So nothing new from my recipe. I know how much I had my raspberries and lime. So let's go ahead and start our equation for number 6. I know I had 1 5/12 cups of raspberries and lime juice. And then I need to go back to figure out, well, how much lemonade at this point? Okay, this was just my raspberries. All right, so it's right here. How much lemonade is in the pitcher? We had 5 7/24 cups. All right, so our equation should match mine, where we're adding our raspberry lime concoction to the lemonade that was already in the pitcher. All right, try this one on your own, looking for that common denominator. Here we have 2 whole numbers. Go ahead and just find your common denominator. Keep your whole number the same. You can check up here and see if you have the same common denominator as me. I did select 24 since I already have 24, and 12 can be multiplied by 2 to get to 24. Go ahead and finish converting your fractions. That's my favorite kind of conversion, where I already have 24ths. I'm going to go ahead and add my whole numbers. And check in to see, does yours match mine? Did you get 6 17/24 cups? Nice work. All right. Oh, so close. Go ahead and type in my answer, 6 space 17/24 to show 6 17/24 cups. All right, step 7, our final step before we get to enjoy our delicious lemonade. Step 7, we need to add the ice. This is a really important step here in Phoenix because without the ice, it's just not going to get cold very fast. So let's add the ice. We have a little bit of ice that we need to add. Now, I already have 6 and 17/24 cups of lemonade. Go ahead and set up question number 7. I have 6 and 17/24 cups of lemonade, and I'm just adding to that the ice. So we can see in our recipe how much ice we need. Go and get your equation set up. The total lemonade that we have plus the amount of ice. See if your equation matches mine down here for number 7, 6 and 17/24 plus 1 1/3. All right, let's see if you remember what to do. Step 1, we need to check for that common denominator. So I am already noticing I do not have the same denominator in both of my numbers, so I do need to find a common denominator. I am just going to keep my whole numbers the same. I set it up and start to think about what kind of common denominator I could use. Well, 24 is pretty big. I'm going to go ahead and check, does 3 go into 24? It does. So I'm actually going to use 24 as my denominator. Okay, go ahead and write those equivalent fractions. So lucky I don't even have to do anything to my 17. Okay, and now I'm ready to add. I'm gonna go ahead and add my whole numbers first. So I'm gonna add my 6 and my 1 to give me 7. And then add my fractions. All right, so mathematically we are now correct. Our total lemonade is 7 25/24 cups. But this is one of those improper fractions where it's bigger on top than it is on the bottom. And so I just want to reduce it, like we always have, to make it into more of a proper fraction. All right, see if you can reduce this one on your own. I'm gonna keep my whole number the same. All right, I got to 8 and 1/24 cups. So this is really helpful. I know when I'm starting my recipe that I need to have a pitcher that can hold 8 and 1/24 of a cup, so a little bit more than 8 of lemonade. So this right here, this jar, this is for pouring it into to drink. This would not hold all of my lemonade. Total, it has a total volume, or it takes up 8 and 1/24 cups. I'm going to practice typing that in. 8 and 1/24 cups of delicious lemonade. All right. I highly recommend you try this recipe yourself. It is quite delicious, quite enjoyable on a hot day, and now we know exactly how many cups it's going to take. We figured this out by adding and subtracting our fractions. We always first looked to make sure we had a common denominator. If we did not have a common denominator, which often we didn't, we had to turn our fractions into equivalent fractions that were equal to the same, but just had a different denominator, the same denominator as each other. Let's go ahead and practice a couple more. You do have 6 problems to try both addition and subtraction. You never know which of these problems are also going to show up on your assignment for today. So you could be knocking out a lot of this work already. Go ahead and set up your paper for question number 1. Let me just make it a little bit bigger. And I'm just going to put some time on the clock, and you're going to go ahead and solve question number 1, 2, and 3, and then we'll check in to see how you're doing with 1, 2, and 3, your 3 addition problems. Go ahead and set it up and get to work. All right, take 20 more seconds to finish up, at least with 1, 2, and 3. It's totally fine if you have not gotten on to number 4. All right, grab something you can check your work with. Make sure if you made any mistakes, you have your corrected work down. All right, let's start off with question number 1. We did not have a common denominator, so when we found one, we found that we could turn both of these fractions into 8s. I didn't need to do anything to my 2 8s. I did need to multiply 2 times 4 to get me to 8, so I did the same thing with my numerator. This gave me 4 8s plus 2 8s for a total of 6 8s. If you got an answer of 6 8s, You could have also reduced it to 3/4, but you didn't have to. Go ahead and give yourself a check. Nice work. Let's take a look at number 2, 5/8 plus 2/3. Here we found a common denominator of 20/4. After we added our 15 and 16 24ths, we got 31 24ths, which is mathematically correct, but we just don't want to leave it as this improper fraction. So we took out 24 24ths, and this gave us 1 and 7 24ths. If you got 1 and 7 24ths, nice work. If you got to an answer of 31 24ths, you are mathematically correct. It is more accepted to write it as 1 and 7 24ths. I want you to push yourselves to write it this way. Question number 3. All right, here we were adding 4/12 and 2 and 4/6. As we found our common denominator, we were in luck. I didn't have to do anything to our 12ths. Kept our whole number the same and turned our 4/6 into 8/12, which gave us, I'm sorry, that should say 2 and 12/12, which we know is the same as 3 because 12/12 is a whole. If you got 3, huge check, nice work. If you got 2 and 12/12, you are, again, mathematically correct. It is more widely accepted to write it as 3. So go ahead and add that in now. If you got all 3 correct, crushed it, nice work. You can give yourself a smiley face. And 3 more to go. These are going to focus on subtraction. So go ahead and I'll put a little bit more time on the clock, and we'll go ahead and pick up with number 4, 5, and 6. Go ahead and get to work. All right, take about 45 more seconds to finish up. All right, let's check in and see what we got. All right, some subtraction problem. So number 4, I actually showed it in 2 different ways. You perhaps turned your denominators into 24ths and got to an answer of 14 24ths after doing 20 minus 6. Or perhaps you used something a little bit smaller and did 12ths and you got to an answer of 7 12ths after doing 10 12ths minus 3 12ths. Both are correct. If you had either 14 24ths or 7 12ths, go ahead and give yourself a check. Question number 5. We turned our common denominator into, or the common denominator we found was 8ths. So lucky me, I didn't have to change anything about 1 and 5/8. I did turn 2 4ths into 4/8. Because I can subtract 5/8 minus 4/8, I was able to keep my whole number the same, and it just left me with 1 and 1/8. If you got 1 and 1/8, give yourself a check. All right, and number 6, the trickiest one. 1 and 1/5 minus 6/10. After finding a common denominator, we saw we needed to subtract 1 and 2/10 minus 6/10. Now, I can't just say 2/10 minus 6/10 is 4/10 because I can't subtract that way. If we think about drawing this out, we have a whole and we have 2/10. I cannot take away 6/10 when I don't actually have 6/10 from these 2/10. So a couple ways we could do this. I chose to take 6/10 from my whole. So if I were to divide my whole and then take away 6 of these tenths, 1, 2, 3, 4, 5, 6, that would leave me with 4/10 here plus 2/10 here for a total of 6/10. I know some of you also like to add up. You also could have turned your 1 and 2/10 into 12/10 and subtracted that way. Tomorrow, we're going to spend more time focusing on questions like this, number 6. If you got to an answer of 6/10 or even reduce that further to 4/5, nice work. Go ahead and give yourself a check. All right, nice work today. A lot of practice adding and subtracting fractions. I know everyone has great notes on exactly how we did this. If you were solving these along with me in the video, you are in great shape for your independent practice this afternoon. Also in great shape if you want to make some lemonade. As a reminder, when you are typing in your answers in your Google form, your fractions are not going to look exactly like these with a number on the top and a number on the bottom. Instead, you will just use the slash bar. So if my answer was 7/12, I would type 7/12. Notice I didn't use any spaces to show 7/12. If I needed to show an answer that has a whole number, so a mixed number, I would type 1 space 1/8. And I would know you meant 1 and 1/8. As always, if you have trouble typing anything in, I will always go back and look at your answers. Also a reminder to please come to office hours. You don't have to submit your work until after you've come to office hours, and you can always get help that way. Can't wait to see everybody at social lunch today and see who has won the next set of prizes. All right, happy work time. See you guys tomorrow.